Okay, so let's get started. I think a minute is already over. So this is the topology that we're going to use today to go over WAN routing. We are simulating that a site which is in one part of the world is trying to connect to its headquarters here. OK, and what actually allows that connectivity is the WAN routing. There is an ISP here to which the site one is connected, site one of the same company, and the HQ is also connected to the same ISP. To simulate the ISP, we have only two routers here, but it could be more than two for sure. Again, if you would like to kind of recollect the way ISPs are connected, what are different types of ISPs, we had a session on this already. If you remember, just as a recap, there will be tier 3 ISPs, tier 2 ISPs, and tier 1 ISPs. Depending on from where to where the traffic has to go, we will decide whether it has to go from tier 3 to tier 2 and to tier 1, or if it is very local, then probably the routing will happen between tier 3 within the tier 3 providers as such. So in this particular example, again, we are not really concerned about um, where these site and HQs are actually located, right? We're just assuming that site one and HQ is in the same location, wherein probably a tier 3 ISPs can actually do that. So that's how the connectivity is. Now, what we're going to do is we're going to understand how um, we're going to understand that how communication happens when a PC, which is this particular PC, PC0, wanted to communicate to the server here, which is having an IP address of 50, 50, 50, 50, 50, 50, 50.50, right? So we will see at each node or each router what actually happens. So we'll start with the PC here. So let's start with the PC and let's see the configuration on the PC here. If I go to the command prompt and then I do ipconfig, what I know is that the IP address of this PC is 192.168. So let's put it full screen so that we can see it properly. For this PC, the IP address of this PC is 192.168.10.100, and the default gateway is 192.168.10.1. Now, the data link address for for this particular PC, let's see what that is. IP config/all, which means this is the physical address, which is the data link address or the NIC MAC address of this particular PC. So how the first question here is, again, when you're going for an interview, this will be the first question that will be asked. How does the PC know? From the topology here, we will be able to see that, you know what, this PC has to send the packet. If it is destined to 50.50.50, which is the server here, it has to send that packet to router 0. But the point is, first question is, how does the PC know that it has to send the packet to router 0? How does it know about router 0? So the answer to that question is the default gateway. So here we see the default gateway of the PC. So if I put it into full screen, I see the default gateway of the PC. For the PC, what the default gateway means is wherever I have to send the packet, whichever destination it is, I don't know. What I do is I blindly going to send that to this particular guy called default gateway. And as a PC, I don't know whether this default gateway is a router, if it is a switch, if it is another device. I don't care about that. Only thing I know is I was told that for me to send a packet to the outside world, I don't need to really care about how to send it. All I need to know is that I need to send it to the next hop, and the next hop is here, the default gateway. So now what happens is uh, this PC goes and tries to reach out to the router 0's G000 interface. What it does is, if you remember our data link layer, We have learned quite a bit about that data link layer in our earlier sessions. What it actually does is that it tries to identify the MAC address of destination MAC address of um, the router G000, right? If you remember in our Ethernet, in our data link session, we talked about Ethernet frames. Forget about preamble startup frame. You remember the destination address? The destination address is the destination address of the router's Ethernet interface. Now, what so when you wanted to create a data link frame like this, you need to know the destination MAC address of the router's interface. So not to know the destination MAC address of router's interface, what PC0 does is it actually sends an ARP request. It sends an ARP broadcast. What it is saying is that what again, what once you go and look at the PC, all PC knows is it knows about a default gateway, which is having an IP address of 192.168.10.0. So what it actually tells is, I don't know the MAC address, but I know there is an IP called 192.168.10.1, which is in the same subnet as mine. Get me the MAC address for that. And based on that MAC address, I will now create a frame as we have seen just now in the data link layer, right? So it knows its own MAC address. If you go back and see the source MAC address of source MAC address is going to be the PC's MAC address, and the destination MAC address is going to be the one that router sends back to that PC. So let's see here. What we're going to do here is I'm going to enable here, and then I say debug IP packet. Now what it does is it actually going to see what happens when it gets a packet destined to any specific destination. So let's try here. So from here, what I now need is this PC is going to, I'm going to ping to 50.50.50. So what it is going to do, I try to ping to 50.50.50.50. It goes to the destination PC. From this PC, it actually goes to this router, which is router 0, which is its exit uh, path to the internet. But if you see the router, what the router does is, if you router knows that this is a source address, which is 192.168.10.100, which is the PC. It understands that. It also sees that the destination that PC wants to go is 50.50.0. But it says it is unroutable because right now this PC has no clue about where it has to send for this packet to reach 50.50.0. Even though that happens, some of the things that actually occurs as part of that is, if you see the show R, you can see that this router has learned the MAC address of this particular PC, which is ending at 9423. If you go back to the PC and then see what is the MAC address of this PC, let's see the MAC address, and you can see here the MAC address actually ends with 9423. So in the process, even though the router R0, and we will see how we can teach router R0 how to send the packet to the other end. But even though it was not able to send the packet, it clearly identified one particular thing. Few things it actually identified. It identified that on my GE000, which is where my LAN is connected, there is a PC which is having an IP address 192.168.10.100, which is having a MAC address that is ending at 9423. Now, how it has known is, as part of the ARP request that has actually come from the PC, it learned the MAC address of the PC itself. And it also sent back its own MAC address to the PC, because now if you go to the PC and then try to see the ARP there, which is ARP -A, you can see that 192.168.10.1's MAC was also learned, which is routers GE000 interface MAC. How do we see that? Show IP interface, and then we say gigabit Ethernet 0 bar 0 bar 0. I think we need to put detail. Show interface gigabit Ethernet 0 bar 0 bar 0. Where does it show? There you go. So you can see here the MAC address, which ends with 4C, let's see, 4C01. So that MAC address of gigabit 0 bar 0 bar 0 of the router was learned by this particular PC. And how it is learned? It is learned through a process called ARP. You can see there are something called ARP entries and stuff like that. That's a different topic we need to cover. But as of now, understand at high level that as this PC try to communicate, it goes only the thing that PC knows is for it to send a packet to any destination, it has to send to the router 0 first. And it actually sends to the router 0, and router 0 identifies some of the information, but router 0, what it told is that, sorry, I am not able to route it, because if you see here, the debug commands for the IP, we saw that this particular destination which you are trying to reach, which is 50.50.50, is unroutable for me. It doesn't know about it. Now, how does a router work when it gets a packet which is destined to a specific IP address? For that, we need to know something called route table. So if I do show IP route on my router, these are the route it has known. So you can see that there are a bunch of chords here, and we have only two of them right now, which is one is C and another is L. C means connected and L means local. You can see that, right? So what that means is this PC has an IP address on each of this interface, and those interface IP address it tells by itself as connected. And L is basically, so if you see C, it is having a network there. So it says that anything in this 192.168.1.0/24, it is my connected network as such. It is directly connected. And my local IP address on that connected network is 192.168.10.1, right? So those are the two things. You can see here as well, it actually does a, a subnetting thing, but you can see here it says connected C, which is 100.1.1.0/24. It does a classful subnetting. We will come to what is classful subnetting and classless later, but right now you understand that it's only understand that there is a connected network which is connected to its own interface. Now our job right now is to educate to this router that for you to reach 50.50.50, you need to go to this particular router's interface here. So from this router R0, we are telling to R0 that for you to reach 50.50.50.0/24, you need to send that packet to router 1, right? So how do we tell that? That process is called, we can do something called static routing. So you do here IP route, sorry, in config T, say IP route, and then you say 50.50.50.0/24 to 55 to 55 to 255.255.0, and then you say for this network to be reachable, you got to send the packet to a particular destination, and that destination IP address is the IP address of this router, which is 100.1.1. Here it is 2, 100.1.1.2, right? So you say here for it to reach 100.1.1.2. Now let's do one thing. Let's again do a ping from our PC and then see what happens. Ping 50.50.50. We'll see what this router R0 says now. Let's see the messages. So you can see here, earlier it told for the destination 50.50.50, it told unroutable, right? If you remember, if you scroll up and then see the message, I think I have missed that message there, but if you remember, it was told as unroutable. But now it says forward. And forward to what? Forward to interface GE0, forward to this IP address 100.1.1.2. The reason is we created this static route over here, right? Now, once you go to the router R1, let's see what happens at R1 again. So let's go here and then do a config T and then do IP or debug IP packet. That's on. Then let's see what this router says. You probably might have assumed what it is going to say. It is going to say that for the destination 50.50.50, it is unroutable because I don't know about this particular network. How do I learn about it? Again, go to the router and then do show IP route. You can see that there is no route in the routing table for the router R1, which is in the ISP, right? But if you see here on the router R0, since we configured using IP route 50.50.50, if you go here and then see and then do show IP route, you can see that a new route has been created here, which is called as 50.50.0/24, and it says via 100.1.1.1, 1.1.2, which is the IP address of router 1, ISP side router IP address, a router interface IP address. Now you can also see that there is something called 1/0 here. This is something called as the weight or metric. We will learn about that, but remember that currently this value, whatever you are seeing here, it has something to do when there are multiple routes to a specific destination. How do I pick and choose that? But that's for, again, another, once we learn about dynamic routing protocol, we'll learn about that in detail. Fair. So now the piece, what happens as part of this process again is, if you see on the router R0, again, let's go to the same command and then do show our table, just show ARP. You can see one more thing here now. It has learned about the MAC address of 100.1.1.2, which is 70001. So let's go here and then see on the router, what is the MAC address of G000? It has to be 7000 ending at 7001. Show interface GE0 gigabit Ethernet 0 bar 0 bar 0. And let us see the MAC address. You can see the MAC address is 700. So what happens at every link as the packet travels from one link to the other link to the other link is two things. First of all, each node, whether it be a router, whether it be a switch, or whether it be a PC, it learns about the MAC address of the peer in that same network, so that whenever there is a communication needed, it can actually create the data link layer packet that we discussed earlier. And then the second part is that as it learns the MAC address, it actually forwards the packet based on whatever is there in the routing table. If there is no route in the routing table, it says I cannot forward it. It says unroutable and the packet gets dropped. And then we teach the router that, you know what, you got to learn about how to reach the destination 50.50.50. So I created something called static route on this router. And now what it knows is that for it to reach 50.50.50, all it needs to do is it has to send that packet to router 1 through this interface G000, which is having an IP address of 100.1.1.1. Now, again, one more, if you go here, router 1 has no clue on how to reach the destination 50.50.50. Here again, we will need to teach this router 1 how to reach the 50.50.50 network. So I'm going to again do a static route, IP route 50.50.50.0, 255, 255, 255.0. And then what will I say? I will say that for read to reach, you have to go to the router 2, which is 200.200.200.2. Show R. Right now, it has learned the 200.200.2. It might have learned earlier as well. But again, if it has not learned, do understand that as part of the process for it to send the packet in this particular link, it has to know about the MAC address MAC address of the interface or MAC address of the router's interface, which is remote. Now this router 1 knows how to, router 1, which is on the ISP side, knows how to send that packet to where to send the packet for it to send where to send the packet for it to reach the network 50.50. Now, what we're going to do is we're going to do similar stuff on router 2 as well as on the router 3, or we'll do only router 2 and then we'll see what happens there. OK, so now let us again do, let's go back to the PC. We will do a ping again. Will it reach? I don't think so. It will reach. Let's go here and then see what happens at router 2. Again, what we will do is enable debug IP packet, and then we'll see what happens there. From the PC, we will do a ping again. We'll go to the router and then see what happens here. So what happens here is you can see that the packet is actually reaching here, but at the router 2, it again says it is unroutable for me. But when you see on router 1, it says, OK, for me, I know that to reach 50.50.50, all I need to do is I just need to forward it to the IP address 200.200.200.2, which is the IP address of this router. If you go to router 0, what it does is it says that, you know what, I don't know the details of it, but all I know is for me to forward the packet destined to 50.50.50, all I need to do is I need to forward it to 100.1.1.2, which is router 1. So now router 0 know how to reach to what to do to reach 50.50. Just forward it to router 1. Router 1 on the ISP side, he know for it to reach a packet destined to 50.50.50, all it needs to do is send the packet to router 2. But router 2, as of now, has no clue what it has to do for it to send the packet to 50.50.50. So let us teach this router that for you to send to 50.50.50.0/24 network to 55 to 50 255 to 55.0 network, it has to send the packet to 201.201.201.3. And what is 3? 3 is the IP address of G000. Let's go and see that. So let's enable show IP in brief. This command will tell you what is IP address, and you see here for G000, it is 200.0.0.1. Let's also enable debug IP packets. Let's go back here. Enter. Now, if you do show IP route, it says that, oh, I have a static route, and the word static means you are statically configuring it. You are configuring it. You are telling the router step by step. Now not only one router. As you see, we have gone to router 0, router 1, router 2. In every router, we are telling where it has to go when a packet for a specific destination arrives. Right. So that is why it is called a static. It is not dynamic. And we will learn. And this is, as you can see, this is a very, very tedious task. This is a not at all a scalable task, because if you are having hundreds of routers, it is not possible for you to do that. Again, as part of this session, what we are learning is how a router forwards the packet across the internet for it to reach a particular destination. What happens in the data link layer? How does each router and PC, which is part of this communication, how does it create the data link headers using the source address and source MAC address and destination MAC address, and how it builds that data link layer packet, and on top of that, how it builds the IP packet so that it can actually send it to the next hop. That's all we are learning. We'll learn about more routing protocols. We'll learn about OSPF RIP in the time as time comes. Okay, so let's continue here. Now, again, what we are going to do is the same exercise. Let's go to this and then see what when a packet comes here, what it says. Oh, yes, I know. What I need to do for a packet that is destined to 50.50 is all I need to do is forward it to 201.201.3, which is this one. Now, here is the question. We added a static route on router 0, router 1, router 2. Do we need to add a static route on router 3 for it to reach 50.50.50.0.1? I'll pose this as a question and I would like you to answer. Let's go and see here. What just happened? If you see here, it's told that there is nothing called, you know, there is something called unrouted here. We'll get to that, but for this is a different packet. OK, we'll say so for the packet which is having a source of our PC, which is 192.168.10.100, destined to 50.50.50. What it told is just forward the packet. Forward the packet to where? GE0001. So let's do this show IP route. You can see here the network or the IP address 50.50.50.50, which is in our topology, the IP address of my server. For it to reach, router 3 already knows that it is connected to its own network. And that is the reason it didn't say that this particular packet is unroutable. Right? The packet which is having a source of 192.168.10.100, which is the PC on the site 1, and the destination is 50.50.50. It says routed via RIB, it is forwarded. OK, so this router don't need to have a static route because it's already having a connected route, which is an interface connected to its own interface, right? So if you do show IP interface brief, you can see that 50.50.1 is something that is connected to this particular interface. If you do show IP interface gigabit Ethernet 0 bar 0 bar 0 bar 1, you can see that this is the network 50.50.1/24. That means an IP address 50.50.50.50 is part of this particular network. How a router identifies that? There is an AND operation that actually happens. Again, that is a topic that we will be covering as part of subnetting. But right now, do understand that an IP address of 50.50.50.50 is within the range of its network. OK, so then, but at the same time, we saw there was something called unroutable that this particular router said. And let me explain you what. What happened just now is across all these routers, so there is a ping packet, which is source 192.168.10.100 to all the way it actually reached 50.50.50. OK, so router 0 no, it has to send that packet to router 1. Router 1 no, it has to send to the router 2, and it reached router 3. And since it is a connected network, or connected, the destination is connected to one of its interface, router 3 know how to forward that packet here. Now what happens is the response packet, the reply packet, it reached, it originated from 50.50.50. That is why you can see here, it told the source is 50.50.50. Earlier, the source was 192.168.10.100, but now the source is 50.50.50 because this is a reply packet. And this router R3 or router 3 has no clue how to reach 192.168.10 network. So what we will have to do is we will have to do the same tedious process of telling each of these router up until router 1, because router 0, it knows it since it is connected network, how to reach the network 192.168.10.0. So the same task, let's do show IP route configuration T, and we'll say IP route 192.168.10.0/255.55.5.0. And then what is the next hop for the router 3? The router 3, the next hop is 201.201.201.2, which is the IP address of this particular router. So we are telling to router 3 that if you wanted to reach 192.168.10.0/24 network, you have to send the packet to router 2's this interface. Okay, enter. Now what happens is, again, you will be able to see that router 2, the router 3 is going to forward the reply packet and router 2 is going to drop it. Let's see that. So ping, and let's go and see here on the router 2 what it says. Okay, you can see that the packet which is having source of 5050, the other packet which is having source 192.168.10.100, it got forwarded, but this guy, it says unroutable. If you go and see on router 3, what does it say there? It says that for the source 50.50 and destination 192.168.10.100, forward it, because now this router, so IP route, knows that it has to send the packet to so and so destination. For 192.168, it knows it has to send it to 201.201.201.2. But this guy, again, it drops because he doesn't know how to reach 192.168.10. network. So show IP route doesn't have that information. We will add that information right now. Configuration terminal IP route 192.168.10.0 255 255 255.0, and the next hop is, let's see the next hop. The next hop from the router 2 is going to be 200.200.200.1, which is IP address of G0001's interface of router 1. Let's see what happens here now. We'll do the ping again, same operation. It's very important for us to understand this end-to-end flow, because until you understand that, it is going to be very difficult for you to kind of troubleshoot all this stuff. So now the router 2 is actually forwarding the packet because it knows where to send. But what happens at router 2? It says for the packet from 192.168.10.100, okay, I can forward it because I know. But for the reverse packet, which is starting at 5050, which is this guy, our server, it says unroutable. Here again, we do show IP route. Okay, so it doesn't have any information on how to reach 192.168.10.0. So I'm going to do educate this router, one at the ISP side, IP route 192.168.10.0 255, 255, 255.0, and the next hop is going to be 100.1.1.1. So now router 1 knows how to send the packet to router 0. Here is a question again. Do we need to send the packet, or do we need to tell the router 0 again, IP route and static route? Do we need to configure that static route for it to reach 192.168.1.0? The answer is no, because if you go and then do enable and then do show IP route, you can see that this router already knows how to reach 192.168.110.network. And 192.168.10.100 is something which is within that subnet 192.168.10.0. So it knows how to reach there. Okay. So we don't need to. So now, ideally, the communication should happen. So let's see. You can see that there was all the packet was lost because it didn't get a response back. Now it should get a response back. You can see here all the routers in the middle uh, now knows how to send the packet. Also, it knows when a response comes back, how should I send it back to the originating network. Now, as you have seen here, the problem with this one is, again, we had how many routers? 1, 2, 3, 4 routers. With 4 routers, it took so much time to configure this particular stuff. And that is the problem with the static routing. It is not scalable. And let's say there are, again, if you go back to one of our topology here, you can see here these ISPs here are actually having a mesh of network, right? I mean, there will be multiple routers at the ISP side. So it is not a scalable solution when it comes to static route for the route learning. And that is where we are having this concept called dynamic routing. We will take one by one. Before that, we need to learn about subnetting as well. So we will learn that subnetting in the next class. I will tell you what is the topic that we are going to cover there. But again, I will save this topology and I will share it in the location so that you guys can actually play around it. Also, I'm going to put a set of questions around this so that the fundamentals are solid and clear for you guys. Also, I'm going to put a link for a one-on-one meeting with me. If you want to prepare for an interview, if you want any guidance, please let me know. Again, I will I'll tell you what my availability on a weekly basis, and we can actually connect for any of those as well. So I'll put both of those links, and then we'll go from there. Okay, that's all for today's session. Have a good one. Bye.